Assalamu alaikum wa rahmatullah. Welcome everyone to Introduction to Industrial Engineering. Today we will continue with our area quality and reliability as one of the areas that we are covering in the Introduction to Industrial Engineering. We covered in the previous session in general what is the quality, and we said that there are many definitions about quality. We identify some of them. We highlight how meeting the customer requirements and the design specifications is how you measure the level of quality, considering that the aspects of cost that represent the value of the product or the service you are providing. Also, we spotted or focused on two major principles in quality, or applications or methods, you can call them. Total quality management. Briefly, we have talked about the total quality management and how it's integrate the entire organization in implementing its principles. Also, we talked about the SPC, Statistical Process Control, and we said we were going to focus on that one. We have covered some of the tools commonly used in SPC, as you are going to explore more in the coming courses in the industrial engineering program. We covered histogram, and we showed an example. Also, we covered the Pareto chart, and we end up with a control chart, and we identify the type of control charts and when we use each type based on the data that based on the type of the data you are collecting. For example, if you are collecting attribute or continuous, and also we distinguish between the two of them. Also, another criteria for making the decision about the type of control chart is the sample size, حجم العينة اللي انت بتقيسها, and how we build the control charts in general. Also, we identify the patterns and what are the different of the variation of variability. There are the common natural variation, and there is the special causes or out of control variation, where the process has to be stabilized and be in control and identify the causes of those events. Also, we just had an overlook of the type of patterns of the data, how they are looking on the control chart. Today, we will continue with the second part of this area. We will talk today about the reliability. Reliability is one of the methods or principles always comes next to the quality, because it's a part, especially for the development in manufacturing and products, it's a part of the major criteria or characteristics need to be there in the products, so it can work for and give its function for the given time specified. Before I'm going to proceed with the definition of the reliability, to understand how the importance of the reliability and why we study the reliability, this is a table shows the cost, the warranty cost in $1 million for many companies in the United States between the years 2000 and 2005 and 6. As you can see, الورنتي كوست هذا اللي هو الضمان اللي بيوفروه مثلا للسيارة ولا للطائرة ولا لليونت اللي انت بتشتريها من هذه الشركة. بيكون في ضمان بتعطى للسيارة فبيصلحوها، يقول لك على الضمان it's fixed and covered. يقول لك it says covered on the warranty. Okay, you don't pay, they fix that. يعني transmission failure, engine failure that happened during the warranty period, the company fix it. Okay, when they fix it, this is not free for them. You don't pay, but the customer, the company, it's going to cost them. And this table shows how much these companies spend on the warranties on those 2 years. The warranty claims اللي هي طلبات التعويضات الضمان. This is $1 million. Okay, so we're talking about thousands of millions. Okay, that's a large number. We are talking about, I know that's maybe long time back. Nowadays, maybe it's improved, but also the number of and number of units produced is larger now. So you are going to expect. Also, this is going to happen when you don't consider the reliability in your products, because it's going to cost you. And remember, when we talked about the cost, is not about you have a high cost, that's mean, or you have a high price tag, that's mean you have a high quality. The quality cost, it's affecting both the customer and the company, and it has to be reduced to the minimum while you are improving your quality. So this is the company, they paid it off due to lack of reliability or implementation of reliability that time. This is also incident happened in Minnesota as a state in the United States. There was a bridge in Minnesota collapsed and caused 13 people died in that bridge. It was on the highway road I-35 West. The interstate stands for the I-35 West bridge collapsed due to lack of reliability in the building. The reliability concept goes widely in all aspects, whether for technology, software application, when you have a software application that allow spies and allow people to or allow viruses to be entered to your system. Also, it can be implemented in product, as we mentioned, in cars, airplanes, like here in Boeing company, or it can be in buildings, constructions. We see, or we have seen many buildings collapsed due to improper implementation of quality in the construction phase. So the reliability is the probability that the system will function. فهي probability, you remember from the probability course, and that's why again we highlight it's one of the major requirement in the industrial engineering, probability and statistics, الاحتمالات والإحصاء. So it's a probability. So the reliability, it's a probability. The system either نظام كامل، برنامج، system، منظومة كاملة، أو جزء، قطعة أو جهاز will function, that means it will operate، يعني هتشتغل over some period of time t. So it will operate over a time period of t. The probability that the system or component will not fail, also this is the other meaning. It's again, it's a probability, but here the system will not fail. Here it says the system will function. Both they have يعني the same meaning، وجهين لنفس العملة. إما نظام لا يخرب في وقت المحدد له في ويكون شغال، أو إنه يكون يعمل بدون أعطال في الوقت المحدد له. فهو إما العمل أو عدم وجود العطل، هي كلها نفس المعنى. Formally defined as the probability that a product, piece of equipment or system performed its intended function for a stated period under specified operating conditions. So it has to be under specified operating conditions. يعني you don't go, for example, if the car capacity in terms of يعني how it's operating regularly, and you maybe overspeed, or maybe يعني you abuse or misuse using the car, so we cannot claim to the reliability that time if you misuse it based on the condition that set it يعني up. I'll give you example. يعني سيارة سيدان or economy car وتاخذها للبر تطلع فيها مثلا، فيعني أول شيء يكون جهد على السيارة لأنه غالبا engine small. ثاني شيء نظام السسبنشن والعجلات اللي فيها ما هي أصلا قابلة لهذا النوع من التضاريس، فلو صار يعني أعطال بسبب هذا الشيء، هذا سوء استخدام. We're not talking about reliability here. We're talking about a condition for that car to be used in streets, in local, يعني in the city. And if something happened while you are using your car regularly, then that we can say it's يعني part of the reliability concept. There are two types of reliability: inherent reliability, achieved reliability. What is the difference? The first one comes in the design phase, and the other one achieved is during the operating phase. In the design phase is predicted. You use certain methods and certain applications. Also, there are software applications to do design for reliability. And the achieved one is the one you observe it while you are operating that product or running that product. Maintainability, it's another concept, also always comes with the reliability when we study the reliability. So we have to highlight it here today. Is the probability again, but the system or product can be retained, or one that has failed can be restored to operating condition in a specified amount of time. What does that mean? قابل للصيانة وللإصلاح وللمحافظة, because retained it doesn't mean إنه في أعطال. restored ممكن أخطاء أو أعطال أو مشاكل تصير، فهو قابل إنه يتم صيانته ويرجع يشتغل again in a specified time. Example like اللي هو periodic maintenance اللي هو trouble shooting أو اللي هو issue failures that you are going to fix. The periodic maintenance, you do it either way. It doesn't have to be the car is going to break down to do it. Periodic maintenance معناها الصيانة يسموها الدورية. هذه بتكون to maintain the car to be operated with the condition or with the specification that has been set for. The other one اللي هو troubleshoot اللي هو إصلاح الأعطال. Things happen, something failed in the car, so you go and fix it within specific time, then it goes and operate again. This concept called maintainability، إنه يكون السيستم عندك أو البرودكت أو اليونت أو الكومبوننت قابلة للصيانة. Maybe also you hear about electric cars these days. They don't require maybe oil change and all these type of maintenance that done in the regular engine that use gasoline, but also treat some kind of maintainability in terms of, for example, software update or tire change or brake changes. So there are some kind of maintainability, but in a different concept. So that's the concept in general of the maintainability. When we talk about failures, if you see in here the reliability, that the probability the system or component will not fail. What is the failure here? When we talk about failure, there are two types of failure also: the functional failure and the reliability failure. The functional failure is occurs at the beginning of the product life. يعني من بداية ما بتستخدمه في عمره الأول بيكون failure happens, and that's usually due to manufacturing or material defects happen during the manufacturing time. The reliability failure after some period of use، يعني بعد فترة من الاستخدام. And those of you يعني look at them and understand them, the reliability, the maintainability, and the type of failures, and many others. There is also other concept, but we will not cover it here since this is not the scope of this course. There is the availability and mean time to failure، متوسط الوقت حتى يصير عندنا أعطال للمنتج أو السيستم. All these are considered in the product design, so they can design even the warranty in the optimal way. اللي هو النظام الضمان المصنعي ما بيتصمم كده عشوائي بيعطيكوا 100,000 أو 5 سنين أو 60,000 و3 سنين. Depend. يعني some people, some companies they give more or less, but this is designed considering all these concepts. They already predicted when this reliability failure, this type, will happen. And they already do some tests to reduce that one, so it will not be a cost to the company and return them to this position again and paying a high amount of cost to repair customers' cars under the warranty. For all these considered, also the schedule for the maintenance, اللي هو periodic maintenance, اللي هو how you do it, whether every 5K, 5,000 kilometer, or 10,000, or some cars with 20,000, depend. So this is also based on the maintainability concept. All these are mathematical concepts and methods. They are not just qualitative, they are quantitative. For example, here, if you look to the to the concept of the reliability function, or the method or the formula of the reliability function, this is how it's presented. So it's something that you calculated and you can analyze it. Probability density function of failure, it's stated as f of t equal lambda exponential to lambda times t, and the time stands to be greater than 0. And the probability of failure, احتمالية حدوث الأعطال، هي 1 minus the exponential or the function of reliability function. So the reliability function is 1 minus this function, 1 minus 1 minus e to 1 minus 1 plus e, because going to be all these in a bracket. So it will give us the reliability function is the exponential to the power lambda times t. هذه الفانكشن that they use it to calculate the reliability. They use it to calculate the reliability. The reliability over the time, this curve representing how the reliability is reduced over the time. And also, if you don't do, for example, if we to understand this concept, خلينا نقول this is the ideal state of a car, and the reliability will be at the highest. Over time, خلينا نقول 5-6 سنين, it will come to this point. طيب إذا أنت قررت إنك you don't do the periodic maintenance, sometimes people للأسف بيستخسر المبلغ هذا اللي بيسويه في عملية الصيانة الدورية، أو أحيانا يكون انشغال أو لأي سبب. This curve will be faster to reduce، حيكون الخط الانحناء حقنا حينزل بشكل أسرع. Where if you do the condition, this is on the ideal condition where is the maintenance is conducted. Also how we use it with the condition that set by the manufacturer, using the same material that's set by the manufacturer. انت اذا حافظت عليها بنفس الارشادات اللي هو المانيوال، الدليل للارشاد للمستخدم. I'm talking here in any products that need maintenance, but I measure for the car always. We use it daily. You are in an age you can sense what I'm talking about rather than talking about something very complex. فانت اذا استخدمتها حتحافظ عليها بالشكل هذا. This is the one designed from the manufacturing, and that if you maintain the system as it's planned for. بس لكن لو انت بدأت ما تحافظ عليها وما تستخدم المواد اللي هي مطابقة لمواصفاتها، سواء من نوع الزيوت or الماتيريال for your component in your car, or you miss the periodic maintenance، هذا الكيرف حيكون أسرع في الوصول إلى reliability أقل. So the failure rate is the number of failures per unit time. الفيلير rate معدل الأعطال في الوقت. هو إيش when we say معدل rate, like speed is rate kilometer per hour. kilometer per hour, this is rate. ما هو كيلومتر مسافة وأور زمن، لكن الاثنين مع بعض يعطونا معدل للسرعة. نفس الشيء failure rate، عدد الأخطاء أو عدد الأعطال، هذا defects خلينا نقول، لكن للوقت هذا معدل لكل دقيقة، لكل ساعة، أو لكل سنة. Okay, this is how we consider the rate. In the reliability, talking also again about the importance of the reliability, I went to that function to explain it to you first, because I wanted to show you that the reliability is based on mathematical formulation and used in the design to specify the amount of reliability of your product or your component or your system, also to predict the failure, as well as to prevent the failure from happening, and as well as when you design the warranty, you design it in the optimal way that also will not cost the company, and it will be saving for both sides, or for the customers and the company. Think about it. After 5 years, rarely you see companies they give you the warranty from the manufacturing for over than 5 years or 100 kilometers, because after that time it's expected to things happen, and sometimes they diagnose your car and examine it after 5 years or 100,000, and they offer you extended warranty with a different lease، عقد ضمان آخر بعد ما يفحصوا سيارتك يتأكدوا إنه حافظت عليها بالشكل اللي هو كان من المصنع، فممكن يعملوا لك عقد إضافي جديد للضمان يتأكدوا فيه إنه أنت حتى لو صار you faced any major failure like an engine, transmission, or the motors like dynamo, electrical اللي هو AC or whatever was that, so it can be also covered under the warranty, but with a separate lease. Some other companies, they don't do that because they expect now it will not worth to do that, because the cost, it will be high than the lease to the company. So all these, I'm talking now from the other perspective. I'm not talking from the customer perspective. I'm talking from the manufacturing perspective, how they design these warranties, also based on the reliability, maintainability concepts, okay? So the reliability used for or applied in many directions to set the standardization for the products, for example, how, as I said, the maintenance has to be conducted, how when it should be, the redundancy, also the physics of failure, reliability testing, اختبارات reliability, all these as a part of the reliability application. burn-in, what is the burn-in? You hear it many times. The burn-in, they do it in the manufacturing to make sure that the system is going to be survive the first failure اللي هو يسموه early failure. Remember when we talked about this one here, the functional failure, هذا اللي هو start at the beginning of the product life. A long time ago they used to say something that you have to do خلينا نقول ايش يسموها دي، انك تخلي السياره تحت التجربه فتره، تمرين يسموها التمرين، هذا المصطلح القديم اللي لحقوا عليه، سياره تحت التمرين when you just purchase a new car. Now somehow it happened, but in a different way. It's more of easier. It used to be, it come to the level you cannot even turn the AC on during that period. You have to drive about 500 kilometers or so before you use the car regularly. Also now some cars has this somehow, you cannot drive it with a high speed and put it to the edge from the first 1,000 kilometers until all the components be lubricated well and all get to the system well. But this is definitely now it's reduced in the new product with the technology they have. And the burn-in test, they do that in the manufacturing by having the component or the system or the product اختبار اللي هو الجهد حتى يتأكدوا إنه early failure this, if it's going to happen, it has to be done and fixed during the manufacturing phase before it goes to the customer, so they can repair it before, and also to avoid it in the other units. اللي هو اختبار الجهد والتحمل، لأنه any early failures this happened, they want to avoid these failures to be during the customer usage, because that will cost the company more. But when it happens during the factory, the manufacturing, it will be manageable. So this is a burn in. Also اختبار الجهد، يتأكدوا من السيفتي of the product when if it's يعني faced يعني accident for the airplane, so it can يعني تعمل في ظروف جدا صعبة، الأجواء يعني تكون مثلا أو الرياح تتحملها الأجنحة حقت الطيارة، فيعملوها لها اختبارات جدا قاسية يتأكدوا فيها إنه الفيلير ريت حق اللي هو early failure rates is not there or it's being resolved before the regular operation. Failure mode and effect analysis, this is a tool or concept or method. Also, we'll learn about it today. We're not going to study all of that, but we will take this one here. It's very common used, and we will discuss it in this session. Fault tree analysis. Here, after the early failure that we talked, here the regular use of the product اللي هو العمر الاستخدام الطبيعي، constant failure rate. So المتوقع الأعطال نوعا ما فيها ثبات ومحدد ومتوقع متى حدوثه، وقدر ما يكون هو to the minimum if you keep a maintenance. After this period اللي هو constant failure rate, we have the increasing failure rate اللي هي بعد العمر خلينا نقول الافتراضي اللي هو دائما متوقع مثلا في السيارات اللي هي المتوسط الأعمار 7 سنوات أو 100,000 أو 150,000. بعد كده يبدأ increasing الفيلير rate. طبعا يفرق من company to company, from manufacturing to other, in terms of the increasing how fast it will be. Some companies يعني start from here, some from here, and some the curve is like that, some others like linear الكيرف بيكون depend on the product. Okay, now for developing a product or a service, you start with the design, manufacture, and then manufacture. This is if we are talking about product. If we are not talking about product, you start with the operation into working. The integration, deployment, and the early life اللي هو بداية عمل المنتج أو بداية اللي هي early life here we're talking about. بعدين the useful life اللي هي الفترة المتوقعة للعمل بعد الفترة الأولى، وهذه بتكون different between product to others. Sometimes very short to some products or systems, and some it's a little more longer. The end of service خلاص هذه بعد ما ينتهي خدمة المنتج أو يقدم العمر الافتراضي له ويكون خلص. During all these phases, how the reliability concept is integrated from the beginning. You create reliability and manufacturable designs. فأنت بتتأكد إنه your designs are reliable. You consider the reliability in the design. في مرحلة التصنيع you reduce the variation for fewer defects. فأنت تقلل من المتغيرات في منتجك وتكون ثابتة على حسب المواصفات اللي حطيتها، وتقلل من الأخطاء في عملية الإنتاج. For the early phase اللي هو الانتجريشن deployment في ال early life have fewer escaping and latent defects. فإحنا نحاول نقلل ال early failures قدر المستطاع في ال early life of the product. Useful life اللي هو this time usually achieve a higher mean time before failure and availability. إيش المقصود اللي هو MTB mean time before failure and availability. فإحنا قدر المستطاع نحافظ على إنه يكون ال product or the system working and function as much as possible without any failures and available for performing its own specified function without any failure. هذا الأوبجيكتيف حقنا في ال useful life. Reliability at the end of the service, how we implemented longer life with our cost. يعني قدر الإمكان إنه end of service نخليها قدر المستطاع، الخط هذا الأحمر نمده قدر المستطاع as long as we can, but what? With a lower cost. Remember, this is the equation for the quality. It's not just to increase the longer life for your product and increase the cost, but also to reduce the cost and increase the longer life, considering an implementation حق reliability. If we are considering the reliability concept, if you are not, this is something else. احنا هنا بنتكلم مراحل التصنيع وكيف تطبيقات الريلايبيليتي في كل مرحلة من مراحلها. quality life cycle، هذه الquality life cycle للتصنيع with the consideration of what? Of reliability. Okay. Moving on to the system reliability، بيكون عندنا 2 or 3 types of system reliability, either series systems, parallel systems, or a mix of both. For the series systems, you multiply the reliability with each other. فإذا كان عندي reliability 0.3 لunit 1 or component 1 and 0.6 for component 2, if I want to find the total reliability for unit 1 and 2, I will multiply 0.3 times 0.6, so the total reliability will be 0.18. For the parallel system, I use this equation to find the parallel system reliability. 1 minus the reliability of component 1 times 1 minus the reliability of component 2 until as many as you have components. So if I have the same 0.3 and 0.6, let's say we have 0.3 and 0.6. The first component, it will be 1 minus 0.3. The reliability for the first one, it will be 0.7. And for the other component, which is the one has 0.6, it will be 0.4. So here we will have 0.4. So 0.4 times 0.7, it will be 0.28. The total reliability will be 1 minus 0.28, and that will give us 0.72. 0.72. If we compare the series reliability to the parallel reliability, the parallel reliability will have a higher usually than the series reliability, but this is usually in the complex system is more expensive. أعطيكم مثال عشان يعني تفهم الموضوع. When we have a parallel system, like your tires, if they break down, or the brakes if they break down يعني تعطلوا، الانجن it's separate، ما حيضرر بهذا العطل. لكن الانجن مع خلينا نقول السبارك بلجز اللي هي الشمعات الاشعال او اللي يسموها البواجي، لما تكون متعطله الانجن كله بيتعطل. طبعا الانجن it's hard to have it independent from many components, so it's somehow series in many components that related to the mechanical system or to the electrical system. لكن some other systems زي مثلا عمود المحور اللي هو الاكسل ولا اللي يسموه العكس او المقصات في السياره، هذه ما هي مرتبطه دايركتلي بالانجن، فالفيلير فيها will not affect running the engine. Okay, it can affect يعني the total يعني خلينا نقول drive experience، ممكن تسمع اصوات، ممكن يعني اهتزازات، لكن الانجن still بعيد من هذه المشكله وممكن اصلاحها independently. So this is how the parallel compared to the series. So you may have a question that a given reliability for a component, and you have to calculate the total reliability for the S, that's reliability for the series system. This is the reliability for the parallel system. how you use the formula. You just multiply here, but here you have to subtract from 1 first for each component, and then you subtract them all from 1, and then you multiply them first, and then you subtract them from 1. You can try using the reliability values that we have explained, and try it yourself at home. For the third type, which is the series parallel system, that contain both parallel and series at the same time. Like this system has A and B components. يعني هذه ممكن يكون نظام الفرامل، هذه نظام مثلا خلينا نقول الهوبات، فهم مرتبطين ببعض. بعدين هنا we have another system that's parallel, is not series, and then we have another series component. Parallel components here are these, they call it the يعني parallel system that's entered during or between B and D here. For example, components, they were in a series, لكن هذا البلوك it's a parallel system. So the way how we deal with this system is we converted to a series system. We converted to a series system. How we converted to a series system? We calculate RC dash, you can call it, اللي هي a combination for the subcomponent for the C. How we calculate the RC dash? By having the same from the parallel system formula, 1 minus RC times 1 minus RC. فإحنا بناخذ القيمة لهذه. طبعا ممكن they can be in different values. يعني ممكن يكون هنا 0.4 و this one يكون 0.7. So I will subtract 1 minus 0.4 and here 1 minus 0.7. I multiply them with each other after the subtraction, and then I subtract them from 1. That will be the series reliability for the C بعد ما حولناه من النظام اللي هو التوازي إلى النظام التسلسلي. طيب. Then I can use the RC dash اللي أنا وجدتها in finding the series system using the same formula, the RS, by multiplying all the values. So I multiply RA times RB times RC dash بعد ما أوجدها times the RD to get the total reliability or the reliability system. It's very easy, and the values will be given straightforward if you are going to have an example for that. So the reliability, and you will have the draw or explanation of the system, and then you just calculate the total reliability. Moving on to another important tool here, we explain that as a part of the reliability concepts and principles is our application is the failure mode effect analysis, FMEA. It's very famous and commonly used to analyze problems before they occur. يعني أنت تحاول إنك بتكون هذه تساعدك في عملية تخطيط في عند وجود الفيلير. How we can even focus and prevent it, and how we can deal with the most frequent failures to either prevent it or to maintain it, and have a set of instructions how we maintain it when it happens. The failure mode is the way in which the component or sub-assembly or product or input or process could fail to perform its intended function. فالfailure mode هو يعني القطعة ولا الجهاز ولا السيستم ولا البروسيس حقتي ما بتعطي أو فشلت في عملها المطلوب منها، هذا نسميه failure mode. الfailure mode and effect analysis, the FMEA, analyze potential problems before they occur. It's helpful for the following reasons. These are the reasons why it's helpful. Allow us to identify areas of our process that most impact our customers. فبنعرف أي الفيليرز اللي commonly بتظهر، فنحاول إنه نحددها اللي هي بتأثر على العملاء بشكل أكبر. And even sometimes you see when you do a maintenance, they give you a questionnaire or survey to respond to that one. That also help them to identify which area in their system or their process of the service was impacting on your satisfaction, so they consider that it will not fail, or if it happened, to reduce it in the future. Helps us to identify how our process is most likely to fail. فأنت تعرف من البداية كيف البروسيس ولا البرودكت will fail. Points to process failures that are most difficult to detect. فتشوف أي أخطاء أو مشاكل بتظهر وبتكون الأصعب في التعامل معها. Types of failure mode effect analysis, either for the design or for the process. يعني either for the product or a system that has component, or for the process itself. يعني عملية الخطوات الoperations اللي في التصنيع والخدمات، يعني either للبروسيس للعمليات أو للتصميم أو المنتج نفسه. Okay, how we do the FMEA? It's a table at the end. يعني you will see it in example. I will show you an example today. It has steps how we proceed doing the FMEA. You follow these steps starting with identifying the failure mode. قلنا إيش الفيلير مود؟ إنه السيستم ولا الكومبوننت ما بتعمل العمل اللي هو المفروض مطلوب منها. Each failure mode has severity level. لكل failure بيحدث بيكون ضرر. نحدد مستوى الضرر اللي بيحدث إما للعميل أو لخط الإنتاج أو للخدمات المقدمة، فنحدد the severity level. Identify potential causes. أسباب الفيلير هذا اللي مود اللي احنا حددناه في الخطوة الثانية، اللي حددناه في الخطوة الأولى عفوا. 4 select an occurrence level. مستوى ظهوره أو تكراره. In 5 list current controls for each cause. حدد أنواع أو خطوات أو إرشادات للتحكم بالفيلير هذا if it happens. 6 select a detection level for each cause. Detection level إمكانية اكتشافه، مستوى أو القدرة على اكتشافه. Some failures it may need diagnosing using some software application to diagnose failure in your system by connecting, for example, computer or specified machines or equipment to your PCM of your car and diagnose the internal component and detect this. Or sometimes it's easily to be detected by just listening to some certain sounds and you can identify them clearly. Or يعني خلينا نقول بعض الأشياء ممكن اكتشافها بسهولة جدا بالنظر أحيانا. Some no, it's hard to detect it. It could happen but you cannot detect it easily. Calculate the risk priority number, RPN. This is very important. This is all about all these steps اللي هي previous 6 steps to get this one. كل الخطوات دي اللي فوق كلها عشان نوصل لل RPN. RPN هو الأداة اللي حنستخدمها ل prioritizing our failures, to prioritize where we should focus first. ال RPN اسمه risk priority number. We will learn how to calculate it. An example. Develop recommended actions. Assign responsible person. Take actions. هذه للمعالجة الفيلير if it happens. Assign and predict severity, occurrence and detection levels and compare RPNs. بيكون عندنا الكل failure mode ممكن يظهر، لأنه الفيلير مود ما هو خطأ أو مشكلة واحدة، ممكن يكون أنواع. after we calculate the RPN لكل واحد منهم, after we find the occurrence والpotential والseverity والdetection level لكل واحد منهم, we calculate the RPN. We compare and see which one has the highest RPN, so we give it the priority to focus on. RPN is the product of the severity, occurrence, and detection scores. السيفيريتي مدى خطورة، فرص تكرار وعودة يعني فرص ظهوره، وإمكانية اكتشافه. These three, you multiply them, severity, occurrence, detection, you get the RPN. Let's see an example. And before the example, we need to know how we put the scale for each one of those: severity, occurrence, and detection. Severity first, قلنا the importance of the effects on the customer requirement. فهو قد ايش مهم للcustomer requirements، فقد ايش ظهوره حيؤذي يعتبر او خطر على الكاستمر requirement. Failure occurrence, frequency، قلنا عدد او ظهوره. failure detection, we explained that. Ability to detect it. Scoring system for each of those three follow either qualitative ولا quantitative. Qualitative معناها high, low, medium, or quantitative using numeric numbers. And for the scale, we can use either 1 to 5. It's easier to do it 1 to 5, whereas 1 may be low and 5 high, or you use 1 to 10. They prefer, it says it's preferred to use 1 to 10 because it's better precision, gives you a larger scale for measuring اللي هو severity or the detection or the occurrence. Now pay attention to this. This is all about this part here, okay? The rating scale for the severity, how it's affecting the customer requirements, is from 1, let's say, to 10. We're going to use 1 to 10 since it's the measure or اللي هو common use, not the scale 1 to 5, okay? 1, not severe. 10, very severe. يعني ايش؟ 1 معناها قليل الأهمية والتأثير على الكاستمر ريكوايرمنتس. 10 مهم ومؤثر جدا على الكاستمر وممكن يبطل يشتري من عندك. اوكي. occurrence not likely to be، يعني يظهر بشكل كبير. عطل ما هو شائع، يحدث بشكل نادر. 10 very likely، هذا عطل شائع، مثلا معروف يقول لك في السيارة الفلانية هذا العطل دائما بيطلع، حساس ولا لمبة ولا ما أعرف شيء معين. شوفوا هذه please pay attention to this. This is the most important part. Detection إمكانية اكتشافه. 1 easy to detect. شوفوا انتبه، easy to detect. 10 not easy to detect، كثير يعمل خلط وعكس، وهذا ينتج عنه RPN غلط، فيعمل تقييم غلط، بريوترايز غلط، كله يصير خطأ. 10 not easy to detect it. It's hard to find it. It's need a special software to find the mistake or the failure or the causes of that failure. عندك check engine light، ما انت شايف ولا مشكلة السيارة ماشية زي يعني regular use حقك اللي هو زي الديلي يوز اللي انت بتستخدم، ما في اي شيء، بيطلع لك check engine light وما في اصوات وما في اي حاجة تعبر انه في خطأ. فهذه ممكن يكون خطأ معين داخل الانجن ما تعرفه او related للانجن، او يطلع احيانا شيء بسيط لكن is not easy to detect. You need maybe special component اللي هو جهاز يشبكه مع يقرأ الكمبيوتر ويشوف نوع الايرور اللي طلع وبعدها يحدده. لكن when you have اللي هو خلينا لمبة البنزين تشتغل خلاص، يعني واضحة هذه ايش معناها. اول امبير حق البنزين اعطاك انه ان، معناها السيارة محتاجة بنزين. او لو باتري for your phone معناها اني باتري. فال10 not easy to detect، ما تقدر تكتشفه بسهولة. ال1 is easy to detect، انتبهوا لهذه، لأن هذه بديهية بتيجي. ال1 اللي هو ما هو مؤثر، وال10 مؤثر، نفس الشيء، لكن هذه العكس تيجي. Pay attention to this one, okay? Now let's take an example and see how we can do the FMEA. The FMEA in the following example is from a project looking at a commercial loan process. In this process, a customer fills out a loan application. The data from the application is entered into a database, and the customer is sent checks. A cross-functional team identified the following failure modes: application filled out incorrectly or data entered incorrectly. فهو إما يكون خطأ في تعبئة النموذج حق القرض، أو يكون الداتا أدخلت بشكل خاطئ. إما الابليكيشن filled incorrectly، يعني تعبئة الابليكيشن كان خطأ، أو الداتا أدخلت بشكل خاطئ في السيستم عندهم. اوكي، يعني في عندهم two divisions، او خلينا نقول جزئين من نوع الداتا انتري فيلير، واحده related للانترينج للداتا، وواحده للابليكيشن نفسها. فعند these are two type of failures. الستيب اللي هي بيطلع فيها الفيلير الكاستمر ابليكيشن. This is the process step or variable of the input، يعني where is the input from the customer application. ايش ال potential failure mode؟ application being filled out incorrectly، اللي هي ال first type of failure، يكون عندنا application filled incorrectly. potential effect on customer because of the defect، اللي هو ايش الامباكت اللي بيكون على الكاستمر. application has to be resubmitted، فهذا شغل اضافي ويتعبى من الكاستمر مره ثانيه، فهذا التاثير or the impact on the customer. اوكي، السيفيريتي ليفل قد ايش هذا بيكون اثره على الكاستمرز. they give it 8 out of 10. and what does 8 mean? Is it high or low? Go to the severity. Is close to the very severe, okay, to the customer specification or requirements. potential causes. what are the causes؟ الاسباب. difficult to understand instructions في الفورم ما هي واضحة خطواتها ومتطلباتها. occurrence OCC. occurrence معناها we explain the occurrence اللي هو frequency أو فرص ظهوره. قلنا من 1 to 10 is very likely to occur, so they give it 6. it's more than medium, so it's closer to the high side, but moderate high, not very high. current process control. what is the control now for this defect when it's happened? check of application form for correct information by data entry operator. so there is an operator who check the application form for the correct information before it's proceeded or before it's sent, so that will reduce the error. This is the current process control. The let's go back here. To find the detection level here, I want you to pay attention. We said 1 is easy to detect, 10 is not easy to detect. For this one, the detection was 2, which means go back is easy to detect. So this is something that easy to be found. Now, what you do to get the RPN? Again, what is the RPN? The risk priority number. Okay, the risk priority number. We multiply all these numbers together as the formula said to get the 96, or 2 times 6 times 8. Okay. For the other input or the other step, the data entry, also we have the third step is data entry also, but here the failure was data entered incorrectly. Also here data entered incorrectly, but the difference is for the customer receives checks with printing errors and data entry error within a single field, or information entered in wrong field. So there are different causes of the same failure. يعني the type of failure mode for the application filled out incorrectly, this is happen from the same or from the same reason اللي هو potential causes the same. لكن for the data entered incorrectly كان عندنا سببين منه. إما بيكون data entry error within a single field، كان خطأ في الحقل واحد من الحقول، أو information entered in wrong field، أو هو خطأ حط المعلومات في الحقل الخطأ. يعني كان إما يكون المعلومات في واحد من الحقول، أو يكون حط المعلومة الخطأ في حقل خاطئ، يعني ما هو related له. الseverity both of them are the same. The occurrence here is 6 and 4. They're a little related, but see here, this one has detect level is 10. That means is really hard to find. So the customer entry error within a single field، عنده خطأ في واحد من الفيلد، معلومة غير دقيقة أدخلها، صعب انهم يجدوا هذا الخطأ، او مو بالسهولة يجدوه، في حين انه هذا اسهل لانه هو بيكون ادخل مثلا العمر في حقل مثلا، يعني حق الاسم، فهنا نوع المعلومة سهل انك انت you find it. لكن هنا بيكون ادخلوا لكن بشكل غير دقيق او غير صحيح، غير مثلا تاريخ الميلاد او حاجة زي كذا، يعني similar to this concept. So this is hard to detect it. So that's why it has a high score, whereas this one is much easier. So it has 5 level of detection، يعني انك مستوى او قدرة انك تجد الخطأ ده 5، في حين هنا 10. Okay. Maybe if you think about it, just came to my mind. That's why many applications that use are these days integrated with a master data system, like what we have in here using Upshare application. This application that you can use it from your smartphone or from the website, all linked to the database of the Ministry of Interior, وزارة الداخلية. فبيكون all the other application related to Ministry of Health or maybe Education, when you enter your social اللي هو national ID number رقم الهوية, some information are pulled automatically from that system, so that to avoid entering any other يعني or يعني entering mistakes في البيسك information زي عمرك، تاريخ ميلادك، بعض المعلومات الخاصة يعني تكون بيك اللي هي موجودة في النظام. So I'm just giving this يعني how this could happen in real life. The severity, again we said for both are 4, يعني they are low in terms of the severity compared to the first one. So we have here a variety of occurrence and variety of detecting level. When you get the RPN, the risk priority number, again you will multiply 10 times 6 times 4, you will get the 240, the same for the this failure. Now you have the total score. You start prioritizing by the highest. So the 240, you can even put a red color for this row here, so you can categorize the one has a highest with red color or identify it with any other color, and then you can put the medium one, like which is this one here. So you can even categorize the one that has RPN from 100 and above, those are high. From 50 to 100, those are medium. From 0 to 50, يعني this is just for organizing and prioritizing. But again, how we solve using the FMEA, this is how you do it. You do the table and you calculate the RPN, and you send your recommendation that you will focus on the highest RPN. In this case, you will focus first on this failure, number 2, to improve the control, to improve or reduce the occurrence of this failure by improving maybe your application or improving some of your system that could also help in reducing this type of mistakes. Okay. يعني أو السبب هنا، شوفوا لاحظ إنه ما في process control فممكن يكون عندك هنا you start to improve process control for this failure. Then the second recommendation would be focusing on this one, failure number 1, because it's the second highest. And then the last one is the data entry failure number 3, because failure number 2 also it has the data entry, but they are different in terms of the causes. This is how you do FMEA tool. It's very useful. You can use it in many applications. In the design, as you remember, the reliability, you can do it for a product, for manufacturing, or also for the service and operations. I hope you enjoyed this session and you like those tools. Also, I will let me show you some resources and references where you can explore or see some software applications about reliability if you are interested to learn more software applications that help in designing for reliability and conduct reliability analysis. Also for statistical analysis, like the one we have covered in the statistical process control. Here are some of the useful resources that you can use it to experience and have hands-on in implementing statistical process control or reliability applications. Minitab is one of the common software application, and you will see it in many of the industrial engineering courses like design of experiments, quality control. You will need a Minitab to use or to conduct statistical analysis, whether design of experiment like regression analysis or factorial design. Also for the quality, conducting quality control charts, histogram, Pareto, all these tools can be done on the Minitab. You can see in the channel on the quality improvement method course, there is a session recorded only for the Minitab review for all the quality tools, how you use the Minitab and how you do it, explaining those tools through examples, and also explain the answers, how we interpret those answers that comes from the results. Also for the statistical analysis, there is the QI macros. It's an add-in software to the Excel, so you don't have to purchase a software independently only for a statistical analysis. Most of you have the Microsoft Office Excel, and then you can just purchase the QI macros and it's added into your Excel, and you also can conduct the statistical analysis tools that you have learned here and you will learn in the future. For the easier interface, I prefer the Minitab in terms of the easy interface, and it looks like the Excel also, but how the tools and how you pull the data and conduct the analysis is more easy. And the company they developed the Minitab, they keep updating this software over the years and enhance it to the customers. For I believe the Minitab, there is there is a lower price for students. You need to have your school ID, university ID, taiba.edu, or any school you are belong to if you're watching this session from other schools, where you can go to that website of Minitab and you go for the discounted price for institutional purposes as a student. They give you a rent for the software for either 6 months or 1 year. All that also explained how you do it on my channel. There is Minitab review, part 1 and part 2 on the quality improvement methods course. You can watch there and see how you download your version using your student email or your Taiba or your university email. For the QI micros, I believe also there is a chance, since it's under the Excel. I haven't tried it before in terms of the lower price, but most of the softwares, they give you a free trials, so you can try them first and see which one you are more like to keep and use. For the reliability that we talked about in this session, there is the BlockSim, and it's very useful software to give you, it's like a platform and provide you for the system reliability and availability. You can conduct the analysis, and allows you to model your system, whether like as we saw in a series or in a parallel, and you put the characteristics for each of those components and then calculate the reliability for you. Also, it can do fault tree analysis for the system. It's very useful and also easy to use. The Weibull Plus, this is another software from the same company, ReliaSoft, stands for reliability software. The ReliaSoft, it's also comprehensive live data analysis tool that performs the live data analysis using or utilizing the multiple lifetime distributions. So helps you to predict the warranty, and also conduct design of experiments, and help you to identify when you should plan for the maintenance schedule for your product, using the distribution or the function, that distribution for the failure and for the availability and for the maintainability of the component. Those two software, they come from the same company, so you can use integrate in terms of the results and the input between them to analyze your system and conduct your experimental design. Even for the burn-in test, you can do it here in the Weibull plus. So these are useful resources if you are going to explore more about the reliability, but definitely the mini tab for the future courses that you are going to take in the industrial engineering, you need to have a software for statistical analysis that you will need it in the future courses. I hope you enjoyed this session. We covered today the reliability, what is the concept of the reliability, why the reliability is important, and we saw how much cost the companies when they fail to implement the reliability in terms of the payoff to the warranty claims. We define the reliability and the maintainability, and we identify the type of reliability and as well as the type of failures. We also explore the applications and methods that under the reliability, like for example, the burn-in, the failure mode effect analysis, the reliability testing, and we use it also for standardization, and how we conduct and implement the reliability in all the phases of the production life cycle, from the design until the end of the service. We explained about what is the burn-in and why they do it for the product to reduce the early failure when the customer used that product. We talked about the probability density function of the failure, and we explain what is the reliability function and what is the failure rate means, and the system's reliability, whether it's a series or parallel or mix of both, and how we convert it from parallel to a series, and how we calculate the system reliability for each one of them. And we end up with the failure mode effect analysis, and we explain it thoroughly, and how we develop the FMEA, and we end it with an example to show how you calculate the risk priority number to use it for prioritizing your failures. And we end up here with some useful resources for your future exploration about reliability and statistics and quality in general. Thank you for watching and hope you enjoyed this session. I will see you soon with other industrial engineering area. Thank you. Goodbye.